Hey everyone, welcome back to Chem Story. Today we're diving into something really important, how to name alkenes. If you've ever seen a molecule with a double bond and weren't sure how to name it the right way, this lesson's for you. We'll go through everything, step by step, so by the end, you'll be able to name alkenes with confidence. Alright, let's jump in. Let's start with step 1. To name an alkene, the first thing you need is the right parent chain. That means finding the longest carbon chain that includes both carbons in the double bond. That part's key. Both double bonded carbons have to be in the main chain. Now if you've got to tie, say, 2 chains with the same number of carbon atoms, pick the one with more substituents. Once you've chosen your parent chain, change the ending from ANE to ENE to show it has a double bond. And that's it for step 1. Let's look at an example. On the left, we've got a chain with 7 carbons, and both double-bonded carbons are included. That makes it a valid parent chain, so we name it heptene. Now look at the one on the right. It's got 8 carbons, so it might look better at first. But only one of the double-bonded carbons is in the chain. That breaks the rule. Remember, your parent chain has to include both carbons of the double bond. So even though the second one is longer, it's not the right choice. Alright, step 2. Numbering the parent chain. Here's the main rule. The double bond needs the lowest number possible. So when you start numbering, go from the end that gets you to the double bond sooner. But if the double bond ends up with the same number from both directions, then what? Then, you pick the direction that gives the substituents the lowest numbers. So we minimize the number for the double bond first, and if that's tied, we go with the one that helps the substituents. Let's put that rule to the test. Check out these 2 structures. Same molecule, but different numbering. In structure A, we number from right to left. The double bond is between carbon 3 and 4, which is nice and low. The substituent lands on carbon 6. This one's correct. Now look at structure B. We number from the left this time. The double bond is between carbon 4 and 5, and the substituent is on carbon 2. But here's the thing. We always prioritize the double bond, so even if the substituent gets a lower number, this way of numbering is incorrect. Bottom line, always give the double bond the lowest number you can. Let's go one step further with another example. In both of these structures, the double bond is in the same spot, between carbon 3 and 4. So now it comes down to the substituents. In structure C, the substituent lands on carbon 5, but in structure D, it's on carbon 2, and that's the lower number. Remember, if the double bond position is tied, you go with the direction that gives the substituents the lowest possible numbers. That's why structure D is the winner. It's not just about the double bond anymore. The side groups count too. Now let's talk about cycloalkenes, alkenes that form a ring. Here's the key rule. The double bond is always between carbon 1 and 2. That part never changes. So most of the time, we don't even bother writing the one in the name. But we still have to number the rest of the ring. And just like before, we go in the direction that gives the first substituent the lowest possible number. So even though the double bond is fixed, we still think carefully about how we number everything else. Let's see that rule in action. In example A, the double bond is between carbon 1 and 2. That's correct. But the ring is numbered in the wrong direction, so the substituent ends up on carbon 2, which isn't ideal. Now check out example B. We number the ring the other way, and now the substituent is on carbon 1, the lower number. So between A and B, B is the correct one. Same structure, better numbering. Here's another example with the cycloalkene. In structure C, we start numbering from the right place. The double bond is between carbon 1 and 2, but the numbering goes the wrong way, so the substituents end up on carbons 2 and 3. Now look at structure D. Same starting point, but we number in the opposite direction. And now the substituents are on carbon 1 and 6. Lower numbers overall, which means D is the better choice. Let's try one more set of examples with substituted cycloalkenes. In structure E, the double bond is between carbon 1 and 2, and we've got a bromine on carbon 3 and a chlorine on carbon 6. In structure F, the double bond's still between 1 and 2, but now there's an ethyl group on carbon 1 and a methyl group on carbon 2. What these examples show is that the numbering rule stays consistent. Always start the double bond at carbon 1, and then number around the ring in whichever direction gives the lowest numbers to the substituents. All right, let's move on to the final step, putting the name together using IUPAC rules. First, we look for all the substituents. That just means the groups attached to the parent chain we just numbered. Then, for the double bond, we use the lower number of the two carbons it's between. That number tells us where the double bond starts, and that's the number we include in the name. So really, this last step is about combining everything, the chain, the double bond, and the substituents, into one clear name. Let's try an example to see how it all fits together. Start by finding the longest chain that includes the double bond that gives us 7 carbons, so the base name is heptene. Then we number it so the double bond starts at carbon 3. That makes it 3-heptene. Now look at the side groups. We've got an ethyl on carbon 3 and 2 methyl groups on carbon 2. Alphabetically, ethyl comes before methyl, so the final name is 3-ethyl, 2,2-dimethyl, 3-heptene. There is another naming style where you'd say hept3-in, but for clarity and consistency, we'll stick with the first version. It's simpler and just as correct. Let's try one more example, this time with a ring. We've got a 6-membered ring with a double bond, so the parent name is cyclohexene. The double bond is between carbon 1 and 2, and usually we don't need to write the 1, it's understood. But if there are substituents, it's helpful to include it just to be clear. Now check out the substituents. A methyl group on carbon 1, another on carbon 5, and an ethyl group on carbon 4. Putting it all together, we get 4-ethyl, 1,5-dimethyl, 1-cyclohexene. Some sources might write it as 4-ethyl, 1,5-dimethyl cyclohex-1-in, but we'll stick to the first version. It's more readable and easier to say out loud. Now let's talk about compounds with more than one double bond. These are called polyenes. If a molecule has 2 double bonds, we call it a diene. If it has 3, it's a triene, and so on. And just like before, we number the chain to show exactly where each double bond starts. So if you've got double bonds at carbon 1 and carbon 4, you'd name it 1,4-diene. We'll go through real examples next so you can see how this works in practice. Let's look at 2 examples of polyenes. First, on the left, we've got 1,3-butadiene, 2 double bonds starting at carbons 1 and 3. Simple enough. Now look at the second one. A bit longer. It's called 3-methyl-1,3,5-hexatriene. That means there are double bonds at carbons 1, 3, and 5, and a methyl group on carbon 3. That's the standard IUPAC name. You might also see it written as 3-methyl-hexa-1,3,5-triene, but that version is harder to say clearly, so we'll stick with the first one. Before we wrap up, there's one last thing I want to mention. Sometimes, a carbon-carbon double bond doesn't show up in the main chain. Instead, it appears as a side group. When that happens, we call it an alkenyl group. There are a few common ones you should know. First, methylene. That's just a CH2 group with a double bond. Next, vinyl. It has 2 carbons, and the double bond is right at the end. You'll see this group all over organic molecules. And then there's allyl, a 3-carbon group, where the double bond is 1 carbon away from the point of attachment. That one's especially useful in resonance-based reactions. So just remember, when a double bond shows up as a substituent, we call it an alkenyl group, and these are the names you'll see most often. All right, that's it for today's lesson on alkene nomenclature. Now you know how to name straight chains, ring systems, and even molecules with multiple double bonds. Thanks for watching, and I'll see you in the next video.